Can you see the whiteboard, Yusuf?
Yeah.
Okay. So factorization in terms of the algebra portion, let me just first introduce you the initial part of it, and then I'll go to the final part of the factorization process.
Okay.
The initial part, it says that when you need to factorize, you need to have an expression with the factors inside it. Means what? Suppose you have a expression like 3x plus 9. If you have 3x plus 9 as an expression, you need to consider what is common between these two terms. These are called terms. So it is a binomial expression in which there are two terms. This one is one of the terms and this is another term. So what is common between these two? Can you just tell me? 3. Very good. So if I take 3 common from the first term, I'll be left out with x, and from the second term, I'll be left out with 3. So if I need a factorized expression, then this is my factorized expression for 3x plus 9, 3 bracket x plus 3. Now, this process of factorization is called grouping. What it is called? Grouping. So we have grouped 3x plus 9, and then we have tried to find out the factors of 3x and 9 and identify what is common between them, separate it out, and whatever is left out, that is another factor which is coming. This is one of them. Second is, in case if you have factorization to be done for this particular expression, say ax plus by plus ay plus bx. So there are 4 terms in it, and we need to factorize this. So what we do, again, we do that same amount of grouping. So now we do the grouping in a different way. Since it has 4 terms, so ax plus ay is one group, and bx and by is another group. Why we have done this? Since we want to take something common between the terms. So can you tell me what is common between these terms? If I group these terms, ax plus ay as one group and by plus bx as another group, then what is common in the first one? Here?
Yeah.
In ax plus ay, what is common?
Ax plus ay.
What is common in ax plus ay? It is
A.
Very good. So a is there in this particular term. It is there in the next term also. So if I try to find out the other part of this expression, x plus y. So now we have got the factorization of this, plus what is common between these two?
B.
So b, x plus y or y plus x, both are same because they follow the commutative law. X plus y is equal to y plus x, since they follow the commutative law. Have you heard about the commutative law or commutative property?
No.
Not really. Okay. So do you understand that x plus y is equal to y plus x?
Yeah.
Okay. This is only possible for addition operation, which is not applicable for subtraction operation, because x minus y is not equal to y minus x. So now, from this expression and this expression, which is common?
Ax.
No, from this expression, this one,
Yeah.
and this one, the common part is x plus y. The common part is x plus y. Why? Yeah, this is common because this is an expression which is present here. This entire thing is present in the first term. This entire thing is present in the second term. So x plus y, if I take it out, I am left out with a plus b. So my factorization of this particular expression is x plus y into a plus b. See if you have understood it. If not, I'll explain it once more.
Can you explain it once more?
I'll explain it once more. I'll do that. The first one is the term called ax. The second one is the term called ay. The one which we have taken, this one, ax term, and we have taken this particular term. The reason for grouping these two terms is I should get a common or something common. That is our entire intention. So here we have got ax plus ay in the first group and by plus bx in the second group. So from these two, what is common? You rightly said a is common. So we have taken out
A.
a. So after taking out a, what is left out? We are left out with x from the first term, the plus sign
And Y.
and y. And similarly, from here also, what is common? That is b common. So we have taken out b, and what is left out? We are left out with y
Y
plus
plus X.
x. So that is what we have written. And then from these two, in totality from these two, what is common? This x plus y, which is within bracket in both the terms. That we have taken out. What is left out? A plus b.
B. Oh, yeah.
So this is my factorization. Now, if you observe, then you might ask that, sir, why can't you take x common? Because I have ax and bx. I will take that as well. And you will get the same answer. Now I will group ax and bx. So let us group this ax plus b
BX.
plus bx. We have grouped it. Ay and by. The other two terms are ay and by. So we have grouped this. After grouping this particular terms and this particular terms, what is common between these two?
X.
X. So let us take x bracket. What are you left out with? A
A plus B.
plus b. Very good. A plus b. Then we take from the next group. What is common in this group?
Y.
Y. And what are we left out with?
A
A
plus B.
plus b. So from these expressions, these are the two expressions now. This and this. What is common?
Wait. A plus
Plus
B.
b. A plus b is common. Very good. A plus b is common. So we take a plus b out. We are left out with x
Plus
plus
Y.
y. Now, if you notice, then this answer and this answer is the same, but you
Yeah.
have grouped it separately. But that does not mean that you will get a wrong answer. You'll get the right answer, provided you have terms which you can actually group. If you don't have terms to group, then you cannot do a factorization. Is this clear?
Yeah.
So let us do one more or two more examples of this factorization and see if you can solve it alone, or else I'll help you out. I'm writing the factor. So just tell me if you can do it. A square plus BC plus AB plus AC. So there are four terms we need to group. Ideally, we should group two terms. Which two should I take
Yeah.
first?
A square.
Okay,
Plus AB.
plus AB. Okay, A square plus AB. So I'm left out with plus AC
BC plus
plus
AC.
BC plus AC. That is what we are left out with. Okay, very good. Now from the first two, what should we take common?
A.
So we have taken A. What are we left out with?
Uh, A square.
No. From A square, you have already taken out A. So you're left out with
B.
only A.
And also
Okay,
B.
and plus B. The
Yeah.
first part, that this particular part falls under exponents. So how good are you in exponents?
Not that bad.
So I'll help you out with that exponents part so that you can understand what to take common. So let me just explain in a brief part. In exponents, what happens is A multiplied by A gives us A square.
Yeah.
The reason behind this is A to the power 1. This is A to the power 1. This is a part of indices, right? A to the power 1 plus A to the power 1 is equal to A to the power 1 plus 1 to give us A to the power 2. This follows a rule of indices, which is A to the power m multiplied by A to the power n to give us A to the power m plus n. We can only do this when the base are same. These are called base. And this is my index or power. So as per the laws of indices, a to the power m into a to the power n is equal to a to the power m plus n. That is exactly what is being done here. A to the power 1 multiplied by a to the power 1 is a to the power 1 plus 1 to get a to the power 2. So we have got here a to the power 2, which is ideally a into a. That is why we have written a and we have got a plus b. From these two, what is common?
C.
C. What are we left out with?
A plus B.
A plus B. So this is two expressions again. From these entire one, what is common?
A plus B.
A plus B. Very good. A plus B. What are we left out with?
A plus C.
A plus C. So the factorization in terms of this particular expression is a plus b multiplied by a plus c, where a plus b and a plus c, they are called factors of that expression. But this is only the first type of factorization, which is called through grouping and associating. So association and grouping is something that we have done. Now, you have understood this.
Yes.
So if I give you a new sum to do, will you be able to do it?
Okay, I'll try.
Okay, that's great. So let me give you a sum and then I'll teach you the second method of factorization. So let us write a x squared plus b y squared plus b x squared plus a y squared. So what should I write first?
AX square
Ax squared, okay,
plus BX square,
plus bx squared, okay.
and then BY square plus AY square.
So I'll write by squared plus ay squared. After this,
After that, we need to take 2. Oh wait,
from these
yeah,
two,
X open bracket.
this is x square.
Okay,
This is x into
X
x,
square.
right? This is also x
Yeah,
into x. So I will take x square common. What I'm left out with?
A A plus B.
A plus b. Just understand that this is x square. Okay. Now,
Okay,
similarly, from the next two terms, what we should take common?
Y square
Y square. Very good. And what are we left out with?
B plus A
So that
or
can I
A
write
plus.
as a plus b?
Yeah,
Because they follow the commutative law. So we
yeah.
make it a plus b. So now what is common between these two expressions?
A plus B
A plus b. And what are we left
plus
out with? Bracket
X square plus
x
Y square.
square plus y square. So we are left out with x square plus y square, which we have written. And these two are the factors of this particular expression. Is it absolutely clear?
Yeah.
Great. So this process is called factorization by grouping. Okay. Now the next part of it, the next part of the factorization uh, chapter is, do you know certain identities of algebra? They are called identities a plus b whole square and a minus b whole square. Do you
Yeah,
know
yeah,
that?
yeah,
Okay.
yeah.
So let me write the first identity as a plus b whole square. Now, what does it give to us as an identity?
A plus.
A plus b whole square is a square
Because
plus,
the square is like out of the bracket.
this can be written as a plus b into a plus b, right?
Yeah.
A plus b into a plus b. But what is the end result? This result, we will write it here. This is called an identity. So how does it get formed? Do you know multiplication of algebraic expressions?
Mm-hmm.
So how do you multiply this? We first write a, then write a plus b, because we are multiplying a with this entire expression. Then
So
we will write
A times
a times a, correct,
A
will be
square,
a square.
and then plus A times B.
A times b will be ab. So this will be a square. A times a is a square. A times b is ab plus
Plus
b times a,
BA
ba, plus b
plus
times b,
B square.
b square. Now again, AB and BA is same because under
Yeah,
multiplication, the commutative law follows. So A into B is equal to B into A. Now these are like terms, right? AB and BA, both are AB rather.
yeah,
So AB
yeah.
plus AB is how much?
AB plus AB.
Is 2AB. Addition of like terms, do you know in algebra?
Yeah,
When you add like terms, only the coefficients gets added. Like for instance, if you have x plus x, how much will be x plus x? It will be
2x.
2x, right? So AB plus AB gives us 2AB. So
Yeah,
this is the final result of this expansion. So let me write this as the final result for this particular expansion. A plus B whole square equal to A square plus 2AB plus B square. This is one of the most important identity of algebra, or rather a very primary identity of algebra. A plus B whole square equal to A square plus 2AB plus B square. Clear?
yeah.
Okay. Now let us